Hello, I'd like to talk to you about capacitance and demonstrate various aspects of capacitance. Here I have the definition of capacitance. It's the ratio of the charge to the voltage. For example, here's a diagram for a circuit diagram for a capacitor showing a capacitor and a battery. And when we hook a capacitor up to a battery, then negative charge will be taken from this plate and brought over to this plate. And we define capacitance as the ratio of the charge on either plate to the voltage across the capacitor, which in this case will be the voltage of the battery. Here I have a capacitor isolated from the battery. Once the capacitor is charged up, we could remove the battery, and we see that there's charge, positive charge on this plate, negative charge on this plate, and we have a potential difference or a voltage across those plates as a result of that charge, and C is the capacitance. And again, the definition of capacitance is the ratio of the charge to the voltage. Next, I'd like to demonstrate capacitance with the aid of this Wimshurst machine. This is a device that works on the basis of electrostatic induction, in which it transfers, say, negative charge to one electrode, taking that negative charge, leaving the other electrode positive. So we end up with one positive electrode and one negative electrode. And I'd like to call your attention to the gap between those two spheres. Now we know it takes a certain critical voltage for a spark to jump that gap. When I turn this crank, I'm going to be turning these two discs in opposite directions. That's going to build up a voltage between those two electrodes. And when that voltage gets to a critical value, and therefore the electric field gets to a critical value, since the electric field depends in part on the voltage, the spark will start jumping the gap. Let me see if we can get that spark to jump the gap, and you'll watch that spark jumping the gap, and it does it with rather rapid fire. Every fraction of a second, a new spark will jump the gap. Now turn the lights down and see if that shows up just a little bit better. Now what I'd like to do is to put some capacitance in the circuit by throwing a switch back here. I'll put capacitance in the circuit in the form of these Leyden jars that we see on either end here. And now it's going to take the same critical voltage for that spark to jump the gap, and therefore the same electric field. And so we see now that it takes a longer time to charge up to that same voltage, indicating that we have more charge with the same voltage. And I'll turn the lights down and see how that shows up. So we notice that with more charge we have a more energetic spark, and the voltage is the same. The charge is greater as the capacitance is increased, showing that capacitance is equal to the ratio of the charge to the voltage. If the voltage stays constant and we increase the capacitance, we therefore increase the charge.